records that Hurricane Melissa broke, and there were a lot of them. We're also going to dig deep into the science, talk about why Melissa became such a behemoth, such a strong storm, and talk about how climate change contributed as well. I'm Chief Meteorologist and Climate Specialist Jeff Baradelli, also known as the Weather Professor. Let's dig in. First of all, as we zoom into this 36-hour loop of Hurricane Melissa, I want you to notice just how concentric and perfect the structure has been with this storm. In all my years, and I've been doing this 30 years, I can't say I've ever seen a storm with such textbook symmetry and structure. Storm made landfall at around noon or so. And as it did, it had winds of 185 miles an hour. It strengthened all the way up to land, which is pretty rare. Had a lot of lightning right around its center. Its pressure was 892 millibars. So that means it was the strongest Atlantic hurricane to make landfall, tying with a storm back in 1935. That was the Labor Day hurricane, which hit the Florida Keys. Overall, the third strongest Atlantic hurricane on record, also a tie. It holds the world record by far for the driest, clearest eye. I mean, look at that eye. It's pristine, not even a cloud in it. And it's the third Category 5 of 2025. That's the second most that we've ever had on record. In addition, we've had 4 storms this year, this being one of them, that went through extreme rapid intensification. That's the most we've ever had in the Atlantic. So let's talk a little about why. First of all, the hottest water in all of the Atlantic basin and the deepest hottest water is right there in the central and northwest Caribbean. Now, what you're looking at here is ocean heat content or ocean heat potential. And what it means is not just the heat at the surface, but the heat that extends way down through the column. So no matter how long the storm sat over the same area, it never used up the heat. There was always more heat to replenish it from down below. What you will notice, though, the path that it took, and it meandered and it moved really slowly, almost like spaghetti, but it did eventually cool down the ocean heat a little bit to the south of Jamaica. Still managed to make landfall as a Category 5, but that is the reason. Deep, very warm water. Now, what's the climate change component? Well, ocean temperatures right under the storm were 2.5 degrees Fahrenheit above normal, but that's the normal of the past 30 years. If we measure that against 40, 50, 60 years ago, well, that number's closer to like 4 degrees Fahrenheit above normal. So climate change made the hot ocean temperatures under Melissa 800 times more likely. And because those water temperatures were so much warmer, not only did it produce more rain, but it likely increased the intensity by around 10 to 15